All right, so here's the review for the final exam. So it's going to be 6, 7, 8, and 12. All right, so we'll go over 8 and 12 tomorrow. Today is 6 and 7. I'm not going to hit every single problem. There's no way. I don't have enough time to do all that. But we'll go through and just kind of maybe go through. Like when it gets down to the algebra, you guys should be able to handle that. Would you agree? Yes. So here we go. So number one, find the sum of the measures of the interior angles of a convex pentagon. Now, this is not the picture for numbers 1 and 2. But do you remember how to do that? Oh, let's change this to red. And even if you don't have to take the test, you can participate, all right? Could use some help here. So what is it again? Is it? If I find all the... So if I have a pentagon, how many sides is that? 5 sides. Okay, so what do I do to that 5? I go 5 minus 2, what? Times 100, not 360, times 180. All right, so that'll find the sum of all the, whatever they are. Okay, so it's 3 times 180, whatever that is. What is that? Whatever it is. Okay, you can do the math. All right, now it says find each interior angle. This time it's an octagon. All right, each interior angle. Well, you start off the same exact way. So you go 8 minus 2 times 180. But that gives you the sum of all the angles. So if it's a regular octagon, it means all the angles are the same, correct? So this tells you how many degrees all the angles add up to be. So how do I find each of them? Divided by what? 8. All right, put that in your calculator and you're good to go. All right. Now, if you have your old tests, you can look to see what the answers are and all that, because if you got it wrong, I put the right answer. If you got it right, you got it right. So you know what the answer is there anyway. All right, what about this? Find the length of each side of isosceles trapezoid. What's true about the sides? Here's the sides right here, this KJ and LM. What's true about those two sides? It's isosceles, so what? They're congruent to each other. So you set them equal, solve for P, plug it back in, boom, you're done. All right, I don't have to go through that tediousness, do I? What about this? Find angle P. How would I find that one right there? Well, you got 4 angles, right? Yeah, so these already add up to what? 180, okay, and that's 122. So basically, well, you could go 360 minus 180, but what's 360 minus 180 anyway? It's 180, so it's 180 minus what? 122, and whatever that is, that's that, okay? Actually, I do have my answers here, so I guess I could write the answers down. So I'll tell you what, I will write the answers down. All right, so this one was 540, and this one was 135. This one right here, it says find all the sides. So this was 8, this was 8, this was 10, and this was 20. Okay, so that's all the sides. Right here, number 4, it's, what did I write? Why did I put that? Anyway, it should be 58. Is that right? 180 minus that? 180 minus 265. Yeah, that's right. Okay. And number 5, what do you do for this? What's true about all 4 of these angles? What do? They all have x, but what do? They add up to 360, right? So you add them all up, set them equal to 360, and then you got to solve for angle P. This is what you're trying to solve for. So once you find x, what do? Multiply by 2, and once you do that, x actually comes out to be 40, so P is what? 80. All right, easy. Everybody with me? All right. What about this? It's a parallelogram. What do we know about the sides of a parallelogram? Because they give us all sides here. Actually, 6 and 7, it's all about the sides. What's true about PS and QR? They're equal to each other. Okay. What about PQ and SR? They're equal to each other. Here's something you may not remember. I don't know, it's been a while since we've done this, but what do you know about the diagonals of the parallelogram? They do what to each other? They bisect each other, okay? So I'm not going to put little tick marks because I already got enough on there, but you get it, okay? PV and RV are equal. SV and QV are equal. Everybody got that? Yeah. So what do they tell you? PS, all right? So they tell you PS, and they tell you they tell you all four sides. So basically, you just set these two equal to each other, set these two equal to each other. It looks like, let's see, QR and PS. Yeah, if you look at it, look, if I set these equal to each other, there's a little bit of an issue, isn't there? Because one's got X, one's got Y. So I couldn't solve for X or Y just with that information. But they do tell you this. They do tell you, they do tell you QR and, what did I say? PS, let's see. PS is what? Let's write it down because I'm trying to do this in my head. I can't do it in my head. RS. Oh, okay. RS is Y plus 2. Sorry. They are not equal to each other, are they? All right. And then QR, which is this one right here, that's 2Y plus 1. And then PQ, this one right here, is X. Now, there's a little bit of an issue. Now, these two are equal to each other. It's supposed to be a Y right there. It's weird looking. Right? These two are equal to each other, and these two are equal to each other. Remember what algebra you're going to have to do here? Substitution. Right, you're going to have to do a little substitution. All right? Because these two are equal, so X is equal to Y plus 2. So what would you put in for this X? Y plus 2. And now you could solve for Y. Once you get Y, you can find X. There you go. All right, so that's kind of the deal here. 7 deals with the diagonals. So PV is A plus 1. And then RV, this right here, is 2B. What's true about those two things? They're equal to each other. But again, there's a little bit of a problem, isn't there? A plus 1 and 2B. You can't really solve for A and B with just that information. You got to know the other two as well. So QV, which is right here, is A minus 1. And SV is B plus 1. Again, you're going to have to set them equal. You're going to have to look at it, do some algebra. You'll have to do some substitution. You're going to have to remember how to do that. So that's not what I'm here for today. We went over it way back in the day. If you go back to chapter 6 on the YouTube videos, watch it, you'll see how to do it. All right. All right, what about here? We don't know it's a parallelogram just yet, but it says, let's find what X and Y should be equal to in order to make it a parallelogram. Well, the math is really the same as what we did before. All you do is just set these two equal to each other. You set these two equal to each other, and these are a little easier. Why are these easier? Because you don't have to do substitution, right? You just set these two equal, and you just solve for X. Set these two equal, solve for Y. Boom, you're done. And that's all you have to do. It says find the value of X, find the value of Y. Let's do this. What do we know about this? Well, we know if it was to be a parallelogram, then this and this would be equal to each other. So what's true about this angle and this angle? Those two are equal. Everybody see that? Cut by transversal, two parallel lines cut by transversal. These two angles would be equal to each other. And this angle is going to equal this angle right there. So again, you're going to have a substitution situation. All right? And you can do that. Again, I'm just scanning through these really quick, just to try to get all this stuff coming back to us, because again, it's been a while since you've done this. But it's only been half a year. Luckily, we don't take a true final exam. True final exam would cover everything from chapter 1 all the way through. Now, when you get to college, that's what's going to happen. It's a while before you guys are going to be in college, but that's what's going to happen. So if you go to another school, a lot of times other schools, if they give a final exam, it covers everything from the first thing you did all the way throughout the whole entire year, okay? So you're lucky that this school doesn't make you do that. They only cover the second half, so that's kind of nice. All right, find the length of the rectangle. It says find QS of PR. Where's PR? That's a diagonal, is 12. Now, this is a rectangle. So they do bisect each other, but there's something else that's true about the diagonals of a rectangle. You can kind of just look at it and tell. What's true about PR and QS? Everybody look at it. Yeah, they're equal to each other, okay? So they are equal to each other. So this is super easy, no math involved. If they tell you that PR, that whole thing right there is 12, right, from P to R, let's put it in red. All right. Oops. All right. So if that whole thing is 12, then what is QS? Oops. Oh, sorry. What do I got to do? There we go. I know I got all that screwed up, but it doesn't matter. But then that's 12 as well. All right, easy. They bisect each other. That's enough of that. What about this? It's a rhombus. All four sides are equal to each other, and it's marked on the thing. Probably didn't have to do that because I told you that it was a rhombus. So all four sides are equal. EFG. What's true about EFG? Angle EFG. That's this big old angle right there. What's true about the diagonals on a rhombus? What do you think about the angles? Look at these angles. What do you think might be true about the angles? It is true that they're all equal, but, well, actually, no, that's not true. This big angle is being bisected. All right, so the diagonal bisects that big angle right there. Everybody see it? So if that's 50, what's this little one right here? That's 50. So if these are 100, then what's this big angle right here? Huh? It's 80. Right, if this is 100, these are supplementary to each other. Remember that? Parallel lines cut by transversal, all that good stuff. Is it coming back at all? Well, it better by the time you take the test. And by the way, the test is on Monday, first period. No, second. We're second period, aren't we? Yes, the second time slot. So whatever that is, 10 o'clock, I think. Okay? All right, so make sure Monday, 10 o'clock that you're here. You get to sleep in, all right? Or you can wake up early and study. Or, I don't know, maybe you have a final first period. Anybody have a final first period? You're the only one? Nobody else in here? Okay. All right, anyway, there you go. And then EHF, that's this one right here. So if this whole thing is 80, what's this little angle right there then? That would be 40, wouldn't it? And look at this angle right here. That's 40 because they're alternate interior angles. There's other ways you could look at it, but that's how I look at it. Okay, let's keep going. Angle B. Again, what do you do here? We've kind of done this already. You add them all up, set them equal to what? Actually, you don't want to do that because you got X and Y. So you don't want to add them up, but you do know something about angle A and angle B. What's true about those two angles? We already said it in the other one. They're supplementary to each other. So you add them up, set them equal to 180. They're both Y's, so that's nice. These are both X's, so that's nice. All right, so you can find angle D by finding X, plug it back in, find Y, plug it back in, and you're good to go. All right? Trapezoid. What's true about this MN? We call that the midsegment. Do you remember what's true about the midsegment? It's not 2/3. It's the average of the top and the bottom of the two bases. All right, so that means you take the top one, take the bottom one, you add them up, divide it by 2, and that equals the MN. But the problem is they tell you MN, don't they? They tell you that that's 43, and they tell you that RS is 54, and they ask you to find PQ. We'll just call it X. So how would you set this up? You wouldn't add these two up and divide them by 2, would you? You're going to add the top and the bottom and divide them by 2, and that's going to equal what? 43. So 43 equals what? The top and the bottom added up, divided by 2. So what do you do? Okay, get X by itself, but what's the first step to get X by itself? Yeah, multiply both sides by 2 and then subtract 54. Yeah, pretty simple. All right. I haven't been giving you the answers to this, have I? I started. Yeah, you can figure it out. Did you hang on to your old tests? You didn't? You should have. Didn't I say that at the beginning of the year? Hang on to your old tests? I said a lot of things that people didn't listen to, but would have been really helpful, right? Would you agree? If you would have listened? All right, let's do this. A kite. What's true about a kite? Well, these two are equal. Also, since it's a kite, you know that this one and this one are also going to be equal. You also know that these opposite angles right here are equal. So if that's 103, then that's 103. Okay? Now, if that's 124, does that make this 124? No, it doesn't. Okay? So what would you do to find angle D? They do ask you. Yeah, do the whole 360 thing again. Yep. Add them up, subtract them from 360, and whatever that is. I don't know. I do have it. It's 30. Okay. All right. And angle A, that was easy. Yeah, that was super easy right there. What's up with this? Remember this one? Find the coordinates of F, G, and H. So this is negative AB. So what is this right here? That's 0, 0, right? So how far over do you go? Yeah, you go over A, right? The distance of that is A, or negative A. So what is it from here to here? Okay, if it's a rectangle, it's the same thing. That's positive A. What about up and down? Remember, this point right here is negative A, positive B. So that's positive B up here, and down here is what? It's negative B, all right? So what's this point right here? It's what? Positive A, positive B. Good. It's an ordered pair, AB. I'm not going to write all these down, but we'll talk through it. What's this point right here? A, negative B. And what's this point right here? H. It's negative A, negative B. Pretty easy, isn't it? Yeah. Slopes. Slopes of FH. That means you're going to go from here to here. So that was AB. This is what? Negative AB. Negative A, negative B, I'm sorry. How do you find the slope? Do you remember that? It's the change in what? Change in y. It's rise over run, so the y is the rise. Okay, x1 minus x2. So what are my y's right here? They're b's, aren't they? So what is it? So let's put b's in here instead of y's and x. So what's it going to be? B minus what? Negative b. What's b minus a negative b? It's b plus b, which is what? 2b. All right, it's supposed to be an equal sign. All right, and then what's the x's? Subtract the x's in the same order. If I went this one minus this one, I'm going to have to go a minus what? Minus negative a, which is also what? 2a. The 2's cancel. What's the slope? B over a. That's FH. You could do EG. What do you think EG is without really doing much math at all? It looks like it's slanted exactly the same, isn't it? Except it's going what? In the other direction. So it would be negative B over A. Yeah, you could do this whole thing if you wanted to, but since that's a rectangle, you know they have the same slope, just one's positive, one's negative. Easy. Yeah. Fill out a pass. All right. Area. Let me sign this pass. Let's just go through some things. So the area, what do we do first? Of a triangle, all right? So the area of a triangle, put AT right there. Remember what the area of a triangle is? Very good. Yeah, that's something you learned as a little kid, right? You should have, yeah. Didn't you learn it as a little kid? Like 6th grade or something like that? 5th, 6th grade, don't you learn the area of it? Yeah, you're a little kid, wouldn't you think? I taught you, some of you guys, in 6th grade, didn't I? That crazy computer class that I absolutely did not want to teach. All right, area of a parallelogram. Do you remember how to find the area of a parallelogram? Negative. This is a parallelogram. It's negative. It's just negative. That's the area.
Oh no, negative. Like I don't know.
Oh, means you don't know. Negatory. All right. So what is it, Angela? It's just the base times the height, isn't it? But what has to be true about the height on anything? When you do area of something, when you talk about the height always has to be what? There's a hint right there. It's always got to be perpendicular to the base. Everybody got it? All right, so right here, did they tell you the height of this? No, they don't tell you the height. So you might have to find the height. All right, you could drop this straight down. But we also have another formula, and I'm trying to remember it now off the top of my head. Do you remember what it is? There is that area with the diagonals. Isn't it the D1, D2 thing? 1/2? Yeah. Okay. It's coming back to me too because I haven't done it in forever. So it's 1/2 what? D1, D2. That's the area of a parallelogram, right? And a rhombus is a parallelogram. So would you go 4 times 3? Is that the diagonal? What is the diagonal here? It's 8. That's right, because that's 4 and that's 3. So it's 8 and 6. Multiply those, take half of it, then you've got it. Okay, so if you have the diagonals, then it's pretty easy. You don't have to find the height, which is nice. Okay. Area of a kite, same thing, isn't it? Same exact thing. So if you know the diagonals, you multiply them together. So what is this diagonal from there to there? 6. And what's the other diagonal? 8. Same numbers, isn't it? All right, so probably the same answer. Yep. Okay. What about a trapezoid? Trapezoid is a little different. It's kind of like a triangle, but it's got two bases. What do I do with those two bases? Add them up. That's right. So you add the two bases together, and you what? Divide it by 2, and then you multiply it by what? The height. All right? So you find, basically, you're finding the average of the two bases and multiply it by the height, and then, yep, and then you're good. Okay? Yeah, it's easy stuff. Oh, circle. We didn't do circle. What's the area of a circle? You should know this. It's pi r squared. That's the area of a circle. It's not 2 pi d. There is no 2 pi d. It's either 2 pi r or what? Pi times d. But that's the see, this is asking for the area. What is the So if it's area, it's pi r squared. So what do you need? You need the radius, don't you? But look what they tell you. They don't tell you the radius. They tell you the circumference of the circle. So what's the formula for circumference of a circle? That's 2 pi r. So what you're going to do, you're going to take that 30 pi, put that in for circumference, and then solve for r, and then you can put it back into here to find the area of that circle. So that was a little tricky. It wasn't super straightforward, okay? So you had to find the radius first, knowing the circumference, then you can put it into this formula and find the area. So you need to know both of those formulas for area and circumference of a circle. Okay, let's keep going. This is an easy one without any math. What is it? Right off the top of your head. Right off the top of your head without doing any math. 30? No. Somebody tell me. 13. Why is it 13? Yeah, it's one of those triple ones. That's right. It's Pythagorean triple. Okay, if you just look at it, remember we learned a handful of them. This is the second one that we learned. What was the easiest, the smallest one that we learned? 3, 4, 5. Okay, and the next one up was what? 5, 12, 13. So without doing any math, you know that that's 13. Does it say that? You thought it was? I mean, you just have to read it, okay? Find the missing length. All right. Sorry for being so nasty, but to me, it's pretty straightforward. You're not finding the area because it says right there. All right. Now, on this one's not quite as nice, so what are you going to do? What are you going to use? Pythagorean theorem, okay? So you can do that. X squared. I'll set it up for you. I'll let you do it on your own. X squared plus 5 squared equals 10 squared, and then whatever you get. Okay? Same thing here, Pythagorean theorem, all right? The square root, a lot of people look at that and they're like, oh man, that's going to make it really hard because they put a square root, but it really doesn't. It makes it kind of easier to tell you the truth, doesn't it? Because what are you going to have? You're going to have x squared plus the square root of 7 what? Squared equals 7 squared. What happens here when you square a square root? They just cancel out, just a 7, that's right. Okay? Everybody good? Yeah, this would be 49, subtract 7, 42, square root of 42. Okay? That's it. Everybody good? All right, how do I know if it's a right triangle, acute, or obtuse? What do I do with these? Take the biggest one, and I put it on the left. Some people, I don't know why, because I never teach it that way, but some people put it in order like a squared plus b squared equals c squared. But on these, I think it's way better putting it c squared first and then a squared plus b squared, because to me it makes more sense. So if it's equal, then it's a what kind of a triangle? It's a right triangle. If c squared is less than a squared plus b squared, what kind of triangle? It's acute, because less than and acute go together, don't they? All right, because acute is less than what? 90 degrees. All right, and then if it's greater than, then what kind of a triangle is it? It's obtuse. Again, greater than and obtuse to me go together because greater than 90 is obtuse, correct? That's what you do. So what is the C, though? The C has to be the longest one. And I think I always put it in order, smallest to largest. But this is the C. It doesn't matter what order you put the A and the B in, but this always has to be the C. So what you're doing is you're taking that and comparing it to this. If this is bigger, then it's obtuse. If this is smaller than this, it's acute. If it's equal, it's right. That's how you do it. And it says, what? Show your reasoning, which means you need to show why. Okay, don't just have a 1 in 3rd chance of writing down an answer and getting it right. You got to show why. Okay, enough of that. I don't know what the numbers are. I don't have it in front of me. What number is this? 11, chapter 7. Let me see. It's obtuse. So this would be 729, and this would be 676. So 729 is bigger, so it's what? It's obtuse. Okay? That's how you do it. Everybody go with that? All right, what about here? Ooh, 45, 45, 90. Remember all that stuff? Let's review real briefly. So if you have a 45, 45, 90, what's true? The leg is equal to, yeah, the legs are equal, that's true. The leg is, I'm sorry, let's do it the other way around. Let's get rid of that stuff. Yeah, let's write it like this. The hypotenuse is what? Remember the number? It's a weird number. Square root of 2. Because look, let's make this super easy. What if that was 1 and that was 1? All right? Do Pythagorean theorem in your head. You should be able to do this in your head to find the hypotenuse. 1 squared plus 1 squared. 1 plus 1 is what? 2. Then you take the square root. So what is this? It's the square root of 2. So the hypotenuse is the square root of 2 times either one of those legs. So the hypotenuse is the square root of 2, what? Times one of the legs. Okay? Now, in this case, that's not what those numbers are in this problem. That was just kind of teaching you that. But they do tell you AB, which is what? 8. So this time they tell you the hypotenuse. How am I going to find the leg? 8. That's it. So it's the square root of 2 times what? AB? Or what is it? The hypotenuse is square root of 2 times, find AC and CB. They're the same thing, so it doesn't matter which one you call it. Let's just call it X. So divide by square root of 2. Divide by square root of 2. If you wanted to put it in your calculator, you could. Let's see, number 12. Do I? I do not put it in my calculator. I just get a... Is that number... Why did I do that? Okay, I guess you could do that. I don't know why I did that. But here's what I did when I made my own answer sheet up for this. I called this X and I called this X, and then I did Pythagorean theorem. All right, but it would come out to the same exact thing. All right, I'm running out of time. We got to keep going. Anyway, 30, 60, 90. What do I know about 30, 60, 90? They both deal with the short leg. All right, I'm just going to show you what this, and this is the long leg, and this is the hypotenuse. All right, so what do we know? They all have to deal with the short leg. The easier one is the hypotenuse. The hypotenuse is how much of the short leg? It's twice. It's exactly twice. And then the long leg, it's a weirder one. It's a square root of 3 this time times the short leg. Do you see how they both have to do with the short leg here? All right. All right, we're getting somewhere. The central angle of a regular octagon. Like, what in the world are we going to do there? Well, here's what I would do. This is where it gets a little bit tough. I'm not going to draw the whole entire octagon. I'm just going to draw, oops, let's keep that straight. There we go. What I'm going to do is this. I'm just going to draw an angle out like this. All right, so that's just like the bottom part of my octagon. It doesn't have to be to scale, but it helps me out a little bit, okay? And then let's say the center is about right there, all right? And then what I'm going to do is go to there, and then I'm going to go to there, and then I'm going to go drop a perpendicular, okay? Now, what I need to do is find what that angle is right there. Now, you guys were starting to say that for that like first problem that we did on the review today, but this is what we do here. How do you find that angle? Remember, it's regular. It's a regular octagon, so there's 8 angles. So what do they all add up to be? 360. So we take 360 divided by what? 8. And what number is this? Oh, it just says find the central angle. Oh yeah, that's super easy. What was I thinking? I was thinking of finding number 15, which is the area. So we'll come back to this, all right? So yeah, that was easy. That was just 360 divided by 8, and that's 45. Okay, so that's 14. 15 is what I was thinking of. That's why I started drawing this thing. Got a little ahead of myself. Regular hexagon. Pretend this is a hexagon. Pretend there's 6 sides to this, okay? And each length of the side is 4. So that's 4. This whole thing is 4. So what's this little bit from there to there? That would be 2, yes? That would be 4, all right? We will find the area. So how do I find the area? The apothem, right? A equals 1/2 the apothem times the perimeter. So we should be able to find the perimeter pretty easy. If each side is 4, then what's the, and that's 6 sides, so it's 4 times 6, which is what? 24. So the hard part about this is finding the apothem. The apothem is which one? It's that perpendicular one right there, okay? Well, it is a hexagon, so I actually know that angle right there. 360 divided by 6 is 60, and then half of that is 30. So if that's right, and that's 30, what's this? That's 60, and now look what I can do. This is my short side, this is my longer side, so we just talked about it right there. So what is A? It's the short side times what? Square root of 3. So the short side is 2, so it's 2 square root of 3. Put it in here, 2 square root of 3, do the math, and then you get what you get. It actually comes out kind of nice and easy, doesn't it? Look, this 2 cancels out with that. You could just write your answer, 24 square root of 3. Everybody good? What's this stuff? Area of a sector, area of a segment. What's the sector? Well, the sector is all of this. Okay, that's the sector. How do I find it? Well, what's the area of a full circle? We already talked about it earlier. What's the area of an entire circle? It's pi what? R squared. But we're not finding a whole entire circle. How much of the circle are we finding? We are finding 90 out of what? 360 of a whole circle. All right, put that in. That's a 10. Work it out, and that's the sector. What about the segment? What's the segment? Let's do this in a different color. Yeah. So all of this. Okay. So how do I find all that blue stuff? Exactly right. Take the triangle out of the sector. Very good. So what do? Find the area of the triangle. Pretty easy, isn't it? Because it's 10. What's this going to be? That's going to be 10. So that's 100. Take 50 out of this. And then it's just whatever your area is minus 50. Right. And you can just keep it like that. And that's the segment. Not too hard. The other 3 aren't that bad, are they? You want to find the shaded region. So what are we going to do? Find the area of the whole thing. Find the area of the sector. Take it away. Boom, you've got your shaded. What about this? Find the area of the whole triangle. Then you find the area of the little circle. Take that circle out of or away from. Subtract it from that triangle. You're good to go. Right here, find the area of the whole circle. Then find the area of the 1, 2, 3, 4, 5 pentagon. Okay, we talked about how to do that earlier, like right here. And then once you subtract those, you got all the gray stuff, and that's left over. Everybody good? All right, look at that. 2 tests in 1 class period. Less than 1 class period because it took a lot of time to do all that. So it'll be online. I don't know if it's going to be very helpful to you. I kind of skimmed through it pretty quick, but it might help you a little bit. Remember some of those formulas that you haven't done in a long time. So tomorrow we'll do 8 and 12, all right? And 12, we probably don't even have to worry about that very much, do we? And then 8 was the circle chapter. So basically, if we know 8, we should be good. All right.